All right, number 22, the number of students taking an exam has increased from 90,000 in 2007 to 420,000 in 2009. And so first thing I need to do is write my ordered pairs. Since I have a measurement of time, and then the other measurement is the number of people, I know that my x or independent variable is going to be the amount of time, and then the dependent variable is going to be the number of students. And I have two ordered pairs here. And I can see that I know that it's going to be a positive rate of change because both my independent and dependent variable are increasing. And so I'm going to take and look at my slope, my change in y. Over my change in x. So we're going to have 90,000. And we're subtracting 420,000. That's going to give us a negative 330,000. And then when we divide that by 2, we're going to end up with 165,000. And if you think about it this way, that our numerator here was the numerator was the number of students. And our denominator was the year. Then we know we're going to end up that this is an increase of the number of students per year. And so that's enough to answer both of our questions. The rate is 165,000, 165,000, and our units or our rate of change is in students per year. Next one is to write the equation shown at the right, and it has y equals, so that means it wants our answer in slope-intercept form. And so if we look right here, this is our y-intercept is at 0.6, and our slope, if we count this, is up to and to the right one, so slope is a positive 2. And so our equation is going to be y equals 2x plus 6. So this one asks us to find the slope of the line. I immediately know that choice B is not an option because undefined is a vertical line. This is not vertical. In fact, I should know by the slant of it that it's a negative slope because it's going downhill. And so I'm going to count 1, 2, 3, 4, 5, 6. That's down 6 into the right. 1, 2, 3, 4, 5. And so that's going to give me a slope of negative 6/5. Write an equation between the altitude and boiling point. If we look at the information here, we have that at 8,400 feet, that the water boils at 201.24, and at an altitude of 4,300 feet, it boils at 206.98. And so it asks us that we need to look at the altitude is the A value in feet, and that the boiling point is this value here, and that's in degrees Fahrenheit. So the first thing we're going to need to do is to figure out the slope here. And so the slope is going to be the change in y. So y1 minus y2 over x1 minus x2. And so let's look at the numerator there, 201.24 minus 206.98. And that's going to give us a negative 5.74. And we're going to have 4100 there. If we take and divide that out, we're looking at a slope of negative 0.0014, and that would be in degrees Fahrenheit per foot. And we're going to need to find the y-intercept for this also. So normally our equation would be y minus y1 equals m times x minus x1. But in this particular problem, they have us using a and b for our variables. So this would be here, b minus b1 equals m times a minus a1. So substituting in, I'm going to use this this ordered pair for my x1, y1. I'm going to have b minus 201.24 is equal to our slope times a minus and so I'm going to have to do the distributive property, because I can see up here that it's in b equals. It wants us to put this into slope-intercept form. So I'm going to distribute here and distribute here. And now I'm going to need to take and work with my inverse and add this to both sides. That'll give me b over here. And I'll need to add it over here as well. So I need to take 11.76 and I need to add it to 201.24. 213. And so this is my first answer. B is equal to a negative 0.0014 times A plus 213. And then it says, what is the boiling point of the liquid at 2,300 feet? So it's giving us this, which is an altitude. And so what we're going to need to do is to take this equation and in place of the A, the altitude, we're going to need to put in 2,300. So it's going to be B equals a negative 0.0014 times 2,300. And I'm going to add 213. So I'm going to go to my calculator and do that multiplication first. Okay, it's going to be a negative 3.22 there. And I'm going to add 213 to it. And that's going to give me a 209.78. And that's going to be degrees Fahrenheit. And that's my answer that goes up here. Determine whether the parallel lines are parallel, perpendicular, or neither. If we look at this, we can see that our slopes are 4/3 and negative 4/3. So for them to be parallel, they have to be exactly the same, which they're not. So parallels out. For them to be perpendicular, they have to be opposite sides, but also reciprocal And they're opposite sides, but they're not reciprocal, so that is out. So that means that they are neither, which means that they intersect, they just don't intersect at 90 degrees. They're not perpendicular. All right, and then our last one asks us to graph the equation y equals 3x plus 4. So our slope is here at 3. So I'm going to go up 3 and write 1. And my y-intercept is here at the point 0, 4. So I'm going to go to 0, 4. And then I'm going to move up 3, 1, 2, 3, and over 1. And that's going to be our line that goes through the intercept at 0, 4 and has a slope of positive 3.